Hey, top of the morning to you, Mr. Klein, in a hat. It's fun. Today we're going to keep messing around with my buddy, the chain rule. That's a chain. So let's look at the situation we're in. I've given you a bunch of information here about f prime and g prime and g. And I'm going to tell you this. We've got a function named Hector. And Hector is equal to Fred of Gary of X. And so this is a chain rule situation because we have an inside function and we have an outside function. And we know that if we want to find h prime of 2, the first thing that we're going to need to do is calculate the derivative function. So think of that as step 1. And there's 2 links in the chain. So I'm going to make 2 links right here. And I know that the first one is always the derivative of the outside. So let's do f prime of something, where that something is g of x, the inside function. We're going to leave alone, just stick it right there. Multiplied by the second one is the derivative of the inside function. So there's step 1. Step 2, let's take this rate of change function and let's plug in 2 like we were asked, which would give us f prime of g of 2 multiplied by g prime of 2. And then I always go after this character first. G of 2, were we told g of 2? Boom, boom, boom. Oh, yes, we were. G of 2 is equal to 1. Therefore, this is really asking us for f prime of 1 multiplied by g prime of 2. All right, so f prime of 1 is 2. G prime of 2 is -3, which gives us my buddy -6. Hey, so basically just another chain rule problem, except for actually a little bit easier, right? Because all you have to do is like look at the functions up here. Let's do another one. K of x is equal to f of x cubed. We want k prime of 2. So once again, step 1 will be to get our derivative function. It's going to be the product of 2 functions. Let's see, here's the inside one, here's the outside one. We start with the outside. The outside would be f prime of, take the inside, leave it alone. Hey, just a heads up, here's a mistake that I see students making a lot, especially when they're first starting to mess around with chain rule, is they'll be like, I gotta take derivatives. So they'll take the derivative of the f, and then they'll also take the derivative of the x cubed. Now that is never allowed to happen. That is a no-no. You can never take 2 derivatives in the same step. If we have already taken the derivative of f prime, we are donesies. The derivative of the inside happens over here. So now second step, problem is asking us for the rate of change at 2. So I'm going to plug 2 in here and here, which would give us the rate of change of f at, if I plug a 2 in, 2 cubed would leave us with 8, multiplied by 3 times 2 squared. So we get, I wonder where that barking's come from. I don't have a dog. I don't. So f prime of 8 is equal to 4. How do I know that? A little birdie told me up here. It's so bad. Oh my God. There's the bird. He's flying. He's telling us that, you know, if birds could talk, they would probably have a lot to say about derivatives. 3 times 4 squared is 12. 4 times 12 is 48. Okay. And the bird is happy. And strangely enough, hairy. Okay, I'm going to be quiet for a second. I would like you to try the third one. Hey, let's check your work. You started by identifying this is the outside function, which means you got 3 times something squared, where your inside function is this multiplied by this. Then you plugged in a 2, which left us with 3 times g of 2 is 1 squared times g prime of 2 is -3. We get my boy -9. Really, where is that dog? Okay, here's one that's a little bit different. Check this one out. It says suppose j of x is equal to f of x squared, where f of x is represented by the piecewise function. Now, the first step is going to be to get our derivative equation, right? So let's go ahead and do that. In this case, there's 2 steps. Outer function is something squared, so I'm going to write 2 times something. Inner function is f of x multiplied by f prime of x. So there is our derivative equation. Let's take that and use it to calculate j prime. So this would be 2 times f of 5 multiplied by the rate of change of f at 5, which would be equal to 2 times, f is this graph. We want 5. Let's see, this is 3, this is 9. So 5 would be, let's see, right here. This would be the y value. Now, it might be helpful to know how this is changing. What's the slope of this line? Let's see. The slope would be boom, boom. So it goes down 3 in the same time that it increases by 6. So the slope is equal to -1/2. Or in other words, every time it goes over by 2, it goes down by 1. So to move over 2 to 5, it would have to drop by 1, which means that this point right here would be 5, 2. And now I can come on over here back to the function, and I can say this is equal to f of 5 is 2 multiplied by f prime of 5, or the rate of change of the function at 5 would be -1/2. We get -2. All right, now let's play the same game at 3. And something interesting is going to happen at 3, because f of 3, let's see, we're at this point right here. Ooh, what kind of point is that, ladies and gentlemen? That's right, this is our buddy, the cusp. All right, so this cusp would be f of 3 is 3, but f prime of 3 would be the slope at a cusp, which is undefined, right? You can't draw a tangent here. You can try. You could be like, boop, but there's no reason that should be the tangent, because like that could be the tangent, or that could be the tangent. Anyway, woo, right? So if any part of this expression here doesn't exist, then our derivative would be undefined. That's our answer. All right, here's what I would like you to do. I'm going to be quiet. I want you to pause the video, and then I want you to work out these 2 problems on your own. Let's check our work now. If you take a look at number 4, 1, I found the derivative equation. Now, if you're wondering why I did that, it's because of this. When the problem says find the slope of the tangent of h of x, it is just another way of saying find h prime of, let's see, since it said at x equals 5, I guess I gotta highlight that. Well, that just means find h prime of 5. So I found h prime of x, I found h prime of 5, I did a bunch of plugging in, came up with 1,000. Let's see if we can make this look like a $1,000 bill. Ooh. Who's on the $1,000 bill? I have no idea. All right, so let's go to, I never had a $1,000 bill before. Hey, quick interruption. This is the $1,000 bill. And that man, that handsome face with that beautiful, beautiful mustache in the middle of the bill is none other than Mr. Grover Cleveland. This bill, incidentally, was discontinued in 1969. Right here, we need the derivative of t. Now, I would encourage you to rewrite that this way. See the negative exponent? Let's roll that into the denominator, which means we would end up with an expression that looks like so. And now we can plug in 5. So s prime of 5 would be equal to t prime of 5 divided by 2 times the square root of t of 5. T prime of 5 is -3. T of 5 is 9. We end up with -1/2. The end. What did that sound? It really sounds like a dog.